Good morning, everybody. At least it's morning for me. And the phrase that often comes up for me when I'm recording videos, and I share what time it is for me. I say, wherever you are, whatever time it is there, I hope it's a good one. We're doing statistics, and we're in module 13, chapter 13. And here's the slide you're looking at on screen is a review of our terminology. We've been carrying this slide with us for many chapters, and we're moving now into some new stuff, right? New module, and we're going to look at experimental design and an analysis of variance. And again, we're learning not only statistics, but we're also learning how to learn, and that's 2 thumbs up. That's a double thumbs up. So I'm showing you how I learn this stuff because, as you've probably seen, if you watched our videos, I'm relatively new to stats. I took stats as an undergraduate, took stats as a graduate student. I got an A. I didn't fully understand it. And now 25 years later, after graduate school, I'm teaching it. This is my 2nd semester, so I'm still figuring it out. And we'll figure it out together. And in figuring it out together, I'm going to show you how I figure it out, which is going to help you learn how to learn. So we talked about this in a previous video, but those are the 2 main things we're going to learn. All right, so experimental design and analysis of variance. And put on your adventurer cap because we're moving into new terrain, and you need to have that spirit of adventure and exploration to venture into the unknown and discover what there is to be discovered. And so that's what we're going to do here. We're going to venture into the unknown, and we're going to learn some new stuff. And then after a little bit of spending time here, it'll start to become known. An introduction to experimental design and analysis of variance. So that's what we're going to take a look at in this module. We're also going to see analysis of variance and the completely randomized design. So we're going to learn more about what a randomized design is. So we're talking about experimental design, and randomized design and what that means. And we're also seeing analysis of variance. And so we're going to see analysis of variance also here. And analysis of variance is sometimes abbreviated as ANOVA. So we'll see that acronym ANOVA, A-N-O-V-A, ANOVA, and left a lot of stuff out there because I'm hitting the wrong key. There we go. So analysis of variance, ANOVA, and multiple comparison procedures. So starting out here with some terminology. Statistical studies can be classified as either being experimental or observational. And just looking at this, I'm just going to indent these because that's kind of like a sub-point. Now let's explore both of those. In an experimental study, 1 or more factors are controlled so that data can be obtained about how the factors influence the variables of interest. And so here we have this word factors, and we're going to learn in just a minute more about that word factors. So we'll see that here. If you want to jump up ahead, you can pause the video, you could read through that, but we'll get to that in just a second. So an experimental study is really about controlling something so that data can be obtained about how factors influence the variable of interest, okay? And I guess to understand that, let's just go ahead and look at the definitions together. We'll go look at that right here. So a factor is a variable that the experimenter selects for investigation in the experiment. It is the primary characteristic or input that the researcher is manipulating to see how it affects the outcome. So it's the input the researcher manipulates, okay? And an example is in a study investigating the effects of different diets on weight loss. The factor could be the type of diet, low carb, low fat, Mediterranean. So those would be different factors. So the factor is the thing which the researcher manipulates to see how it affects the outcome. The outcome here would be weight loss. The factor would be different diets, and so these would be the different diets. Now treatment is just like if factor is the main point, treatment's a subpoint, and treatment is like the broken down different factors. Okay, so a treatment is a specific level or condition of a factor that is applied to the experimental unit. So it's a specific level or condition of a factor that is applied to experimental units. We'll learn about experimental units over here in a second. Well, I guess we'll learn about it right now. An experimental unit, like if it's the diet thing, the experimental unit would be the subjects, the subjects or the elements that you are applying factors or treatments to to see if it changes the outcome. Okay, so in the diet analogy, it'd be the different people. And some people would get one diet, one factor, one treatment. And other people would get a different diet, a different factor, a different treatment. And then maybe some people would get no diet, and that would be their factor, their treatment. They would be the control group. And then we'd look to see how did the outcomes vary amongst our experimental units, the different people who are in our study. It's kind of a clinical cold phrase to refer to people. But we would see how did the different factors or treatments influence the outcomes on our experimental units, the subjects, the people that were in our study. So treatment is a specific level or condition of a factor that's applied to the experimental unit. And again, statistics, the statisticians, not so great with English, and there's a lot of jargon. And so you're learning a new language here, right? And it's the language of statistics is what you're learning, all these different phrases and how people talk about statistics, or statisticians talk about statistics. In some cases, a factor may have multiple levels, and each level is referred to as a treatment. Example, if the factor is diet type, the treatments could be low-carb diet, low-fat diet, Mediterranean diet. Each of these represents a treatment applied to different groups in the experiment. So that's what factors and treatments are. And experimental units are the objects of interest in the experiment to which treatments or factors are applied. These are the entities upon which measurements are taken. They are the smallest division of the experimental subjects or items that receive the treatment. Example, if you are testing different diets on weight loss, the experimental units would be the individual participants in the study. All right, so pause the video here and just reflect upon that and kind of look those over, and if you get a pencil and a piece of paper and maybe draw yourself a little diagram. And in that diagram, you might put experimental units, and then you might have factor, and then AKA treatment, right? And point that towards the experimental unit. So the factor of the treatment would be pointing towards the experimental unit, the people, and you apply a factor of treatment to people, to the experimental unit to see, and then you might have an arrow coming out here to see the outcome. As a matter of fact, that's such a good idea for a diagram. I'm gonna make it. Why don't you make it too, and let's compare them. I'll see you in just a second. All right, here's the drawing I came up with. You take a factor, also known as a treatment, and you apply it to experimental units, and then you measure the outcomes. You look at the outcomes, and if you randomly assign the factor of the treatment, that is known as a completely randomized design. So if you say just randomly, you're going to get the Mediterranean diet, you're going to get the low-carb diet, you're going to get no diet, and you randomly assign different factors or treatments to experimental units. And for me, so treatment is the subcategory of factor, but for me, they're used interchangeably, just in my own head. That's how I read them or understand them. And I also understand that treatment is a subcategory of factor, right? But that's kind of the diagram I came up with. I hope you came up with something that makes sense to you. And then here's the last phrase here, completely randomized design. So a completely randomized design is an experimental design in which the treatments are randomly assigned to the experimental units. So the treatments or the factors are randomly assigned, right, to the experimental units, and this is a completely randomized design when you do it that way. This design ensures that each experimental unit has an equal chance of receiving any of the treatments, which helps in eliminating biases or confounding variables. So confounding variables, if you're confounded, you're confused. So if you look up confound, define, cause surprise or confusion in someone, especially by acting against their expectations, mix up something with something else so that the individual elements become difficult to distinguish. Let's hear how you pronounce it.
Confound.
Well, let's hear that again.
Confound. 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 Confound.
Confound. So confounding variables would be things that, confuse your results or mix up your results. And biases would be like if you're like assigning certain diets, like maybe the person you hire to assign the factor of the treatment, the diets, to the different experimental units is like, you know what? Guys love what's the meat diet, the keto diet or something, whatever it is. Guys love that diet. So I'm going to give all the guys the meat diet because they like to lift weights, right? So maybe they have some bias. And then that's going to confuse your results. because you didn't just randomly assign it to people to see what happens. There's some bias in there, and you have a confounding variable, right? Like now men are more likely to have been eating the meat diet in this experiment, and that could confuse the results. So randomly assigning things, having completely randomized design helps eliminate those, what do they call it? Confounding variables and biases. It eliminates those biases and confounding variables. So in an experimental study, one or more factors, aka treatments, are controlled, which diet, giving diets to different people, so that data can be obtained about how the factors, the treatments, the diet, in our example, influence the variables of interest. In the variables of interest would be like weight loss, I think is the example, right? And so here, weight loss, right? So that would be the variable of interest would be weight loss in this example, and we'd see how there's weight loss right there. We'd see how changing the factor, the treatment, the diet, and assigning randomly, so we have completely randomized design, different treatments to different experimental units, we would see how different diets help individuals, people, our experimental units, realize this variable that we're interested in, which is weight loss, okay? So again, learning the language of statistics, the terminology, a lot of jargon in statistics. In an observational study, no attempt is made to control the factors. So you're just going to observe the way things are. And so an example of a situation where you have to have an observational study is smoking and health. You can't create a completely randomized design and say you're now going to start smoking and you're not. And let's see how that impacts your health. That's just not ethical. And so you just observe people who have already chosen to smoke, what's their health like, and people who haven't chosen to smoke, what's their health like. And so there's no attempt to control the factors or the treatments, which in this case would be smoking. Do you smoke? Do you not smoke? That'd be the factor of the treatment. And the variable of interest would be, how does that impact your health? Does it decrease your longevity? Decrease your longevity if you smoke. Does it make you die earlier? It does. And then the experimental units would be the people to which those factors or treatments are being observed, right? But in an observational study, you're not applying factors or treatments. You're just seeing what is already occurring in the world, in nature. Cause and effect relationships are easier to establish in experimental studies where you could control the factors and the treatments that you apply to the experimental units to measure variables of interest. So cause and effect relationships, right? Does this diet cause weight loss? Are easier to establish in experimental studies than in observational studies. Analysis of variance, ANOVA, can be used to analyze the data obtained from experimental or observational studies. So, variance, if you remember, analysis of variance, just to break that term down. So a measure of central tendency would be like the mean. And so here's the mean. And we could have 8, 10, 10, and 12. And the mean is 10. And then our variance is really kind of tight around the mean, 8, 10, 10, and 12. Or we could have wider variance. We could have 2, we could have 4, we could have 16, and we could have 18. So our data is more dispersed. Our mean is still 10, but we have more variance. And so now doing an analysis of variance can see, like, when we look at like our results, were they really spread out or were they really tightly coupled and less dispersed? And that could give us some information about, allow us to draw some conclusions about our results. So in this chapter, 3 types of experimental designs are introduced: the completely randomized design, a randomized block design, and a factorial experiment. And so we've already learned what a completely randomized design is, and we'll see more about this, I'm sure, as we move through this material. So again, if you want to pause the video and review that, there it is. And then here again is my drawing, and it kind of shows you completely randomized design. And now we're moving into the last slide, and you can see I do things where the headings are all green up here. And so our last slide here is just another definition that the textbooks provided. A factor is a variable that the experimenter has selected for investigation. A treatment is a level of the factor. Right? Like if you didn't already have this explanation, you'd be like, what? Experimental units are the objects of interest in the experiment, and a completely randomized design is an experimental design in which the treatments are randomly assigned to the experimental units. So now that we've reviewed, this page here and this page and this drawing here, all of that makes sense, which is great because that's what we're here for, to have things make sense to us. All right, that's just some terminology to get us started. See you in the next video where we're going to learn about analysis of variance, a conceptual overview. See you in the next video.